Dear student, previous class we discussed about the molecularity, types of reaction depending upon the molecularity, characteristics of molecularity, distinction between molecularity and order of reaction, kinetics of zero order reaction and characteristics. Now I will discuss about the kinetics of first order reaction. According to the definition of first order reaction, the reaction in which the rate of reaction depends upon only the concentration of one reactant. That is called first order reaction. Suppose I will take a first order reaction. A gives B plus C. Here A is the reactant, B and C are the product. At initial condition, the time is equal to 0. Suppose the concentration of A is small a moles per liter. At the initial state, that is your T is equal to 0, the concentration of B is 0. And also the concentration of C is also 0. After time t, suppose x mole of A is converted into x mole of B and x mole of C, then the concentration of A at time t equal to A minus x moles per liter. The concentration of B is your x moles per liter and the concentration of C is your also x moles per liter. So we can write at time 0 the concentration of A equal to A moles per liter. This is your taken left. After time t, suppose x mole of A is converted into x mole of B and x mole of C. So after time t, the concentration of A equal to how much? A minus x moles per liter. The concentration of B equal to x moles per liter, and the concentration of C is how much? X moles per liter. According to the definition of first order reaction, the rate of reaction depends upon the concentration of one reacting species. So the instantaneous rate, that is your dx by dt equal to k into concentration of the reactant. That means the concentration of A. Here power 1 is written because this is your first order reaction and the rate of reaction depends upon concentration of one reacting species. That means we can write dx by dt equal to k into the concentration of A after time t equal to how much? A minus x. So here we can write A minus x power 1. Now I can write dx by dt is equal to k into A minus x. This is your said to be differential rate equation. Differential rate equation. This equation is called differential rate equation. Now we can write dx by A minus x is equal to k into dt. Now integrate the equation. Now integrate the above equation, then we can write integration of dx by a minus x equal to k into integration of dt. After integration, I can write minus ln a minus x equal to kt plus I, where I is called integration constant. Suppose I will take this is your equation number 1. Now our aim to find out the value of I. When t is equal to 0, then x is equal to also 0. Now put the value of t and x in the equation 1. We can find ln a is equal to k into 0 plus I. That means I can write I is equal to minus ln a. This is your suppose equation 2. From equation 1 and 2, we can write minus ln a minus x equal to kt minus ln a. Imply that I can write ln a minus ln a minus x equal to kt. Imply that ln a by a minus x is equal to kt. We know that ln x minus ln y equal to ln x by y. So we can write here ln a minus x is equal to ln a by a minus x. Now I can write x is equal to 1 by t ln a by a minus x. Now convert the ln into log. So we can write k equal to 2.303 divided by t log of a by a minus x. We know that ln x is equal to 2.303 log x. So here ln a by a minus x is equal to 2.303 log of a by a minus x. This equation is called integration rate equation for first order reaction. Now I will discuss about the half-life period for first order reaction. It is denoted by T half. Half-life period is defined as the time in which the reactant is reduced to 1/2 of its initial concentration. So here we can write T is equal to T half and x is equal to a by 2. We know that k is equal to 2.303 divided by t log a by a minus x. This is the integration rate equation for first order reaction. Now put the value of t and x in this equation. We can write k is equal to 2.303 divided by t half log of a by a minus a by 2. Now I can write k is equal to 2.303 divided by t half log of a by 2. That means we can write k is equal to 2.303 divided by t half log 2. We know that the value of log 2 is your 0.3010. So we can write here that k is equal to 2.303 divided by t half log of 2 means 0.3010 because log 2 is equal to 0.3010. Now multiply the 2.303 into 0.3010, then we can find 0.693. So we can write k equal to 0.693 divided by t half. Imply that T half is equal to 0.693 divided by K. This is the half-life period expression for first order reaction. Look at that, here K is constant, 0.693 is also constant, so T half is equal to constant. That means for a first order reaction, the half-life period is always constant. So we can write the half-life period for a first order reaction is constant. Look at that, here the concentration of reactant, that is your A, is not written here. We know that A is the initial concentration of reactant A. That means the T half value do not depend upon the initial concentration of the reactant. So we can write the half-life period for first order reaction do not depend upon the initial concentration of reactant. Now I will explain about the characteristics. The half-life period of a first order reaction do not depend upon the initial concentration of the reactant. So we can write the half-life period do not depends upon the initial concentration of the reactant. Remember, all the first order reaction obey this reaction, that is your K is equal to 2.303 divided by T log of A by A minus X. So we can write the second point, all the first order reaction obey the following equation. That means K is equal to 2.303 divided by T log of A by A minus X. Suppose I will plot a graph between log A minus X and T. Suppose time T is taken in the x-axis, log A minus X taken in the y-axis, then a straight line is obtained which incline the log A minus X axis. Suppose this is your O, this is your A and this is your B. If I will plot the graph between log A minus X and time T, and the time is taken in the x-axis and log A minus X taken in the y-axis, then the slope equal to minus K by 2.303. It can be proved by the help of this equation. Now convert the equation like this, log A by A minus X equal to Kt divided by 2.303, imply that log A minus of log A minus X is equal to Kt divided by 2.303. Now log A minus X is equal to minus Kt divided by 2.303 plus log A. Now compare this equation with the y is equal to mx plus c. Here log A minus X is considered as y, which is taken in the y-axis, and t is taken in the x-axis. As a result, the value of m is equal to minus k by 2.303. So we can write m is equal to minus k by 2.303, which is equal to slope, and we know that slope is equal to OA by OB, and we can write log A minus X by T. By taking this graph, we can write a point, the graph between log a minus x versus t shows a straight line which is inclined to the log a minus x axis. Next characteristics point is the value of rate constant do not influenced by the change in concentration unit. The unit of rate constant for first order reaction is second inverse. This is all about the characteristics. Now I will do some problem related to the kinetics of first order reaction. My first problem is show that for the first order reaction the time required for 99% completion of a reaction is twice the time required to complete 90% of the reaction. Such type of problem play an important role in the exam. Always such type of problem come in the exam. In this reaction there are two cases. Case 1 is 99% completion. Case 2 is 90% completion. This is a first order reaction. For first order reaction, K is equal to 2.303 divided by T log of A by A minus X. For case 1, let A is equal to 100. According to question, X is equal to 99. Therefore, A minus X is equal to 100 minus 99. Now put the value of A and A minus X in this equation. Then we can write K is equal to 2.303 divided by T log of 100 by 100 minus 99. Now I can write K is equal to 2.303 divided by T log 100, and the 100 is converted into 10 square. So we can write K equal to 2.303 divided by T log 10 square. We know that log of x to the power y is equal to y log x. Now convert this, that is your log 10 square is equal to 2 log 10. So we can write K equal to 2.303 divided by T into 2 log 10. The value of log 10 is your 1, so we can write imply that K is equal to 2.303 divided by T into 2. Suppose for case 1, to distinguish the time for case 2, we can symbolize this T as T99. That means here also we can write T99, here also T99, this is also T99, here also T99. This is only the symbol to represent the time for case 1. For case 2, let A is equal to 100. According to question, X is equal to 90. Therefore, A minus X is equal to 100 minus 90. Now put the value of A and A minus X in this equation. Then we can write K is equal to 2.303 divided by T log of 100 by 100 minus 90. That means we can write K is equal to 2.303 divided by T log of 100 by 10. That means we can write K is equal to 2.303 divided by T log 10. The value of log 10 is your 1, so we can write K is equal to 2.303 divided by T. For case 2, this T is represented as T90. Here also we can write T90, here also we can write T90, here also we can write T90. This is your suppose equation 1, this is your suppose equation 2. For a particular reaction, the value of K is constant at constant temperature. Now, from equation 1 and 2, we can write 2.303 divided by T99 into 2 is equal to 2.303 divided by T90. implies that we can write 2 into T90 is equal to T99. That means T99 equal to 2 into T90. Here we can write proved. Here also we can write proved. Now I will solve the problem number 2. A first order reaction takes 40 minutes for 75% decomposition. Calculate its half-life period. In this question, T is equal to 40 minutes. Let A is equal to 100. Then according to question, 75% decomposition, that means X is equal to 75. Therefore, A minus X is equal to 100 minus 75. We know that K is equal to 2.303 divided by T into log of A by A minus X. This is the expression for rate constant for a first order reaction. Now put the value of T and A minus X in this equation. Then we can write K equal to 2.303 divided by 40 into log of 100 by 100 minus 75. Now I can write K is equal to 2.303 divided by 40 log of 100 by 25. Now I can write K is equal to 2.303 divided by 40 into log 4 because 100 by 25 is your 4. Next is your K is equal to 2.303 divided by 40 into log 2 square. That means K is equal to 2.303 divided by 40 into 2 into log 2. Implies that K is equal to 2.303 divided by 40 into 2 into 0.3010 because the value of log 2 is 0.3010. Implies that K is equal to 2.303 into 0.3010 is equal to 0.693 divided by 20 because we can cancel the 40 into 20 by 2. Again we know T half is your 0.693 divided by K. Now put the value of K in this equation. That means T half is equal to 0.693 divided by 0.693 divided by 20. By solving, we can find T half is equal to 19.97 newton. Now I will solve the problem number 3. The half-life of two samples are 0.1 and 0.4 second respectively. Their respective concentration are 200 mole per liter and 50 mole per liter respectively. What is the order of reaction? Before solving this problem, it is bound to remember a formula T half 1 by T half 2 equal to A1 by A2 whole to the power 1 minus n. Here n is the order of reaction. A1 is the initial concentration of sample 1. A2 is the initial concentration of sample 2. T half 1 is the half-life period for sample 1. T half 2 for the half-life period for sample 2. In this problem, A1 is equal to 200 mole per liter and the corresponding T half 1 is your 0.1, A2 is your 50 mole per liter, T half 2 equal to 0.4. Now put the value of A1, A2, T half 1, T half 2 in this equation. Then we can write 0.1 divided by 0.4 equal to 200 by 50 to the power 1 minus n. Now solve this, then we can write 1 by 4 equal to 4 to the power 1 minus n. Now I can write 1 by 4 equal to 1 by 4 to the power n minus 1. Here nothing means 1. From these two, it is clear that 1 is equal to n minus 1, implies that n is equal to 1 plus 1, that is your 2. That means the reaction is your second order. So we can write the answer. The order of reaction equal to 2. Now I will solve the problem number 4. The reaction 2N2O5 gives 2NO2 plus O2 was studied and the following data were collected about this reaction. This is the data given in the table. Here two experiments done, experiment 1 and experiment 2. In experiment 1, concentration of N2O5 is your 1.13 into 10 to the minus 2 and the rate of disappearance of N2O5 is your 34 into 10 to the minus 5. In experiment 2, concentration of N2O5 is your 0.84 into 10 to the minus 2 and the rate of disappearance of N2O5 is your 25 into 10 to the minus 5. Find the order of reaction. Let the order of reaction equal to n. We know that according to rate law, R equal to K into concentration of R power n, because the order of reaction is your n and this is the expression of rate of reaction according to the rate law. For a particular reaction, the value of K is constant at a constant temperature. Now apply this equation to experiment 1 and experiment 2. For experiment 1, I can write 34 into 10 to the minus 5. This is your R for experiment 1. So here we can write 34 into 10 to the minus 5 for R and K into the concentration of R, that is your reactant, is your 1.13 into 10 to the minus 2 power is your n. Suppose this is your equation 1. Now again apply this equation to the experiment 2. The value of R is your 25 into 10 to the minus 5. So we can write 25 into 10 to the minus 5 is equal to K into here the concentration of the reactant is your 0.84 into 10 to the minus 2. So here we can write 0.84 into 10 to the minus 2 power n. Suppose this is your equation 2. From equation 1 and 2, we can write 34 into 10 to the minus 5 divided by 25 into 10 to the minus 5 equal to K into 1.13 into 10 to the minus 2 power n divided by K into 0.84 into 10 to the minus 2 power n. Now cancel the K. Now I can cancel the 10 to the minus 5 and finally I can write 34 by 25 is equal to 1.13 into 10 to the minus 2 divided by 0.84 into 10 to the minus 2 power n. Next is your 34 divided by 25 equal to cancel the 10 to the minus 2 and I can write 1.13 divided by 0.84 power n. After solving 34 by 25 we can get 1.36. Now solve 1.13 divided by 0.84. I can write 1.35. Here power is given and the power is your n. Here nothing means power 1. 1.36 and 1.35 are nearly equal to each other, so we can write here n is equal to 1. The question is your find the order of reaction, so we can write the order of reaction is your 1. Now I will solve the problem number 5. Consider the following data for the reaction. Here a reaction is given, A plus B gives product. There are 3 experiments are given. Initial concentration of A and initial concentration of B and also initial rate is given in the table. Determine the order of reaction with respect to A and with respect to B and overall order of reaction. Remember an important point. Suppose I will find the order of reaction with respect to A, then always remember the concentration of A only affect the order of reaction. So it is not necessary to include the concentration of B. When I will calculate the order of reaction with respect to B, then it is not necessary to take the concentration of A in the calculation of rate of reaction. When I will find the overall order of reaction, then I can think about the concentration of A and B both. According to the table, I can write 2.1 into 10 to the minus 3 equal to K into 0.10. Suppose I will take the power P into 1.0 power Q. Here P belongs to the order of reaction with respect to A and Q belongs to the order of reaction with respect to B. Suppose this is your equation 1. Similarly, I can write 8.4 into 10 to the minus 3 equal to K into 0.2 power P into 1.0 power Q. This is your equation 2. Similarly, I can write 8.4 into 10 to the minus 3 equal to K into 0.2 power P into 2 power Q. This is your equation 3. Suppose I will find the order of reaction with respect to A. Then it is not necessary to include the B concentration term. So our aim, how can I cancel the concentration of B? There are 3 equations are present. If I will take the equation 1 and 2, then look at that, here 1.0, here also 1.0 is written. That means when I will divide the equation 1 by equation 2, then at that time the concentration B term will be cancelled. So at first I can write from 1 and 2, we can write 2.1 into 10 to the minus 3 divided by 8.4 into 10 to the minus 3 equal to K into 0.1 power P into 1 power Q divided by K into 0.2 power P into 1 power Q. Now cancel K. Next cancel this term. Again cancel 10 to the minus 3, 10 to the minus 3. Now I can write 2.1 divided by 8.4 equal to 0.1 to the power P divided by 0.2 power P. Now I can write 21 by 84 is equal to 1 to the power P divided by 2 to the power P. Imply that I can write 1 by 4 equal to 1 by 2 to the power P. Imply that 1 by 2 whole to the power 2 is equal to 1 by 2 whole to the power P. Imply that 2 is equal to P, that is your P is equal to 2. P is the order of reaction with respect to A. So we can write the order of reaction with respect to reactant A equal to 2. Now I will find the order of reaction with respect to B. That means it is necessary to include the concentration of atom. Look at that. If I take the equation 2 and 3, then the concentration atom will be cancelled. So I can write from 2 and 3, we can write 8.4 into 10 to the minus 3 divided by 8.4 into 10 to the minus 3 equal to k into 0.2 power p into 1.0 power q divided by k into 0.2 power p into 2 to the power q. Now I can cancel this term, again cancel this term, again cancel this term. Simply I can write 1 equal to 1 to the power q divided by 2 to the power q. Now I can write 1 by 2 to the power 0 is equal to 1 by 2 to the power q. That means q is equal to 0. So we can write the order of reaction with respect to B equal to 0. We know that the order of reaction with respect to A is 2. Now I can find the overall order of reaction, means order of reaction with respect to A plus order of reaction with respect to B. That means 2 plus 0 equal to 2. So the overall order of reaction is your second order reaction. Finally, we can conclude that the order of reaction with respect to A is your 2, the order of reaction with respect to B is your 0, and the overall order of reaction is your 2 plus 0 is equal to 2. Now I will solve the problem number 6. The following data were obtained during the first order thermal decomposition of N2O5 gas at constant volume. The reaction is your 2N2O5 gas gives 2N2O4 gas plus O2 gas. The data present in the table related to this equation. Our aim to find out the rate constant for first order reaction. Look at that, your pressure is given, your molar concentration is not given. According to the first order of reaction, we know that K is equal to 2.303 divided by T log of A by A minus X. Here A and A minus X are the molar concentration, but here pressure is written, so it is bound to change the molar concentration into pressure. So I can write P initial divided by P 100. P 100 means pressure at 100 second. Here T is given, that is your 100 seconds, so we can write 2.303 divided by 100 log of P initial means that is your 0.5, but remember P 100 is not given. Our aim to find out the P 100. The equation is your 2N2O5 gas gives 2N2O4 gas plus O2 gas. At time 0, the pressure of N2O5 is your 0.5 atm, and the pressure of both N2O4 and O2 is your 0 atm, because there is no formation of the product at the initial condition. After time 100 seconds, there is formation of some N2O4 molecule and O2 molecule, and there are some unreacted N2O5 molecule. Suppose after 100 seconds the pressure of oxygen is your x atm, then the pressure of N2O4 is your 2x atm. Like that, the pressure of N2O5 is your 0.5 minus 2x atm. These are written according to the coefficient of the reactant and products. After 100 seconds, the total pressure equal to the pressure of N2O5 and the pressure of N2O4 and the pressure of O2. So we can write after 100 seconds, the total pressure is equal to 0.5 minus 2x plus x. In the table, the total pressure is your 0.51, so we can write 0.51 equal to 0.5 plus x implies that x is equal to 0.51 minus 0.5 equal to 0.01 atm. After 100 second, the total pressure of N2O5 is 0.5 minus 2x. So I can write P N2O5, that is the total pressure of N2O5 after 100 second, equal to 0.5 minus 2 into 0.01. That means 0.5 minus 0.02 is equal to 0.48 atm. We need the pressure of N2O5 at 100 second. That is I can write here 0.48. Now I can solve this. 2.303 divided by 100 into log of 50 by 48 implies that 2.303 divided by 100 log 50 by 48 is 0.017. Finally, the answer is 3.951 second inverse.